guys, welcome back to Rocket Gyan, my fellow space tubers. Today we are here to see the another awesome rocket launch of this great sounding rocket which is in front of you. And just sit tight and relax, and I'll try to explain everything which is necessary. Sorry. Uh, Yeah, I will explain everything which is necessary to see this launch and to know about this. So, how are you guys? Hi, KK. Hi, Sheila. Shelia or Sheila. Yeah, Sheila. Hi, Astra. Hi, Rick. Right. Hello, officer. So, okay, just a sec here. Is this visible on the East Coast as well? Everything will be I will tell you everything which you need to know. So just sit back and let me just see if we have the stream right now. Are we having the stream from them? Nope. Fine. So we can continue with our discussion. So today we will be seeing the launch of the Terrier-Improved Malemute rocket. This is in front of you how it looks like. This is a two-stage rocket, and this is a sounding rocket, which means it will just go straight up and then come down. Okay, so it's not like Falcon 9 which will go straight up and enter the payload into the orbit. That will not happen with this rocket. This will go straight up, reach space, and then open the payload payload doors or so, and then it will do the experiment. So these sounding rockets are mostly used for conducting the short term experiments, and today is one of those experiments which we will see. We saw the launch of such a rocket with an Aurora creation payload. So that was a pretty epic launch, I must say. Many people watched it from their homes, clicked photos, videos, and tagged us on Twitter, and we just looked at it in the live stream itself. So if you are watching this stream right now and maybe want to tell us how you are you watching the launch, whether you will be seeing it personally or what, you can tag us on the Twitter. At the red rocket gyan is my handle. Okay, so this is a two-stage rocket. Okay, and talking about some more characteristics about this rocket, so here you can see a bit of you know um, detailed version of this rocket. So first of all, this first stage is a Terrier Mark 70 or Mark 12 motor, and the second stage is the improved Malemute motor. Okay, so since these are the terms which I'm using are the motor, which means that they support the solid rocket fuel. The solid rocket fuel which they are using for this mission will be HTPB, and yeah, so that is the case here. Let's get one thing straight from the beginning. That's not a rocket, that's a dart for a big boys and girls. Yes, well, full battery, if you can say it like a big javelin throw, which you actually don't throw, but launch it with the poof of solid fuels coming out of the rocket. So yes, that is the case. And right now this is the thing which you are saying and talking about the some characteristics about this rocket. So first of all, this rocket is runs, the first stage is the Mark 70 or Mark 12, whatever they want to use according to the mission. They use the Terrier motor which they use. It's a very powerful rocket motor, and yeah, and the second stage which they use is the improved Malemute motor, which we all know. So, and this is a spin stabilized rocket, which means uh, the spinning is induced in the rocket, which is actually used to stabilize it so that it does not, fall in either any direction, and just go away from its intended trajectory. Because when you are spinning something like a spinning top, when you're spinning a top, it stays upright in upright position and does not fall in any direction. uh, but when it is just resting, it just falls. So that's how spin stabilization works. So when a rocket is launching and just in the upward direction, and it is spinning also, it helps the rocket to keep in that position where it is heading. Okay, and it does not just change the trajectory because of the wind and all those things. And let me just tell you and this straight that this rocket is an unguided rocket, which means the nozzle, the engine or the motor is not gimbal approved. Okay, so the gimbaling is not there, the TVC, thrust vector control, is not there. So it is totally, I can't say totally, but most of it just depends on the weather and the atmospheric condition. So that's why the weather plays a big role here. And the payload capacity for this one is around um, it has been launched for around 600 to 900 pounds. And um, the height which it has achieved is around 300 to 150 kilometers, which depends on the payload which we are carrying. If we have a heavier payload, then obviously the apogee, the highest point in the trajectory, will be less than what we expect for a lighter payload. So yes, that is the case here. If you have any questions, guys, you can ask me. The acceleration during the boost phase, yes, KK, you are very right, is 26 Gs, which means when this booster is actually this rocket is actually going up into this space, the acceleration which it experiences is around 26 times what we experience on the Earth, which means 26 times the Earth's gravity. So this 26 Gs of load is so huge that I don't think so any humans can survive. Although aircraft, army, the aircraft pilots are trained for handling high Gs, but then they also can handle around 9 to 12, maximum 15 Gs. 26 Gs is can kill you, seriously can kill you because of stroke. And if you know what I'm talking about, why am I talking about stroke? Because if you have seen Expense web series, you know what I'm talking about. When you are under high acceleration, you tend to get a stroke, and Expense uh, explains that phenomena beautifully with their web series. So yep, angular momentum, yeah. Okay, now let's have a look at the payload adapter for this thing. So the payload adapter actually looks like this. um okay, let me just have a look, change it this thing a bit. So this is a motor part. This blackish part is actually a motor which has a solid fuel, and this upper part, reddish part here, is actually the payload adapter, or means the not the payload adapter, actually the payload bay where they actually put the payload experiments and whatnot. So this is actually not like a fairing which opens up and then the payload is exposed to the space and deployed. That is not the case with this rocket. There is these shielded covers which are there, and they open up and expose the payload bay to the space environment. So this is how the payload bay looks like. And notice that this payload bay itself has this these doors, and these doors are actually very responsible for exposing the payload to space. So these doors open up, whatever payload or whatever experiments the rocket is carrying, it gets exposed to the space, and then it can carry out the experiment. So that's how the things work. And you can see that it's very complex system in here. The avionics and all those materials which are needed are placed in here. So yeah, that is the case. Now we have talked a lot about the rocket, how the payload is and what not, but we haven't talked about the payload which it is carrying for today's launch, for the VIPER launch, right? But before knowing about the payload, we should be knowing about the Van Allen radiation belts, because this payload is going to kind of study those belts, those effects on belts, not exactly the belts, but yeah, somewhat related to belts. So yeah, so first of all, we need to understand what those Van Allen belts are, radiation belts are. So this is an image which actually summarizes the whole concept which I'm trying to say. So we have these two types of radiation belts surrounding the Earth. Okay. Um, Radiation belts, what do I first of all mean by radiation belts? So there are certain regions around the Earth where the most of the energetic plasma particles, or you can say the ionized particles, are trapped because of the Earth's magnetic field. So the Earth's magnetic field actually looks like this, right? It goes from the south pole and goes onto the north pole. So this the ionized particle has this property, you can say, that it follows the lines, follows along the magnetic field. Okay, so yeah. So, because of that, since the plasma particles are ionized and the plasma particles are always there in space because of solar winds, because of cosmic rays or whatever, so ionized particles are always in the space. And since the magnetic field is significant of Earth, so these ionized particles get trapped around the Earth, and those particles actually get trapped in these two belts, the inner radiation and the outer radiation. So uh, there are certain regions, and basically two regions, around which the most of the particles reside, the inner and the outer. Now if I so talking about the inner and outer, let me just have a look. Okay, see this, guys, I wanted it to you all to see this. So this belts are actually donut shaped, which you can see here. These are the outer belts and this is the inner belt. So this is the inner belt, which actually rises, you can say that it comes from around 700 kilometers to 8,000 miles. That's how the range of this belt is, the inner belt. And the inner belt basically contains the protons particles. Okay, this is the smaller one here. And then we have this outer belt, and the most dangerous one is the outer belt, because the inner belt is like more stabilized one. And whenever a solar storm happens or a geostorm happens around the Earth, the inner one is more or less stabilized. Okay, just because first of all the protons are heavier particle, it needs some higher energy particles to deflect it. So, and it is very near to the Earth, so yeah, you can say that these inner ones are kind of stabilized. But the problem arises with the outer belt here, the outer belt, which ranges from 12,000 to 25,000 miles. And so yeah, this, because this belt is variable and it keeps on changing as per the space weather, as per the ionized particles in the space attacking the Earth or what not. So uh, yeah, just a sec. Current time for the launch is around T minus 1 hour, guys. And if you have any questions, you can ask me. Otherwise, if you are, loving the stream and the knowledge which I am giving, you can just give the stream a like button and maybe share it with your friends also. So uh, that would be good. Otherwise, yes, let me just talk about this belt and why am I very concerned. Why are people or scientists concerned about these belts? Because first of all, guys, see this. We have this huge void between the inner belt and the outer belt. So there is one empty space area, and this is the area where most of the satellites, most of the human space flight missions work, because those satellites and those human space flight missions do not want to cross the radiation belts, obviously, because it can change the radiation doses are obviously harmful for the humans, as well as radiation can cause the a single event failure, which actually changes the bit of the computers, and maybe just changes the data basically for the computer, and computer does not operate properly because of those radiations, those high radiation. So this is where the most of the things operate. You can see here the ISS is at low Earth orbit around 230 miles, and the inner belt starts for around 600-700 kilometers, and the ISS works at 450 kilometers, so it is near the Earth. That's fine. Now, if we look at the GPS satellites, it operates for at around 12,500 miles, and the outer belt usually ranges from around 12,000 to 25,000 miles. But as I have said that uh, outer belt is very variable, and it can just expand in space or decrease in space or whatever. It is variable. So the GPS satellites are very close to this one, and whenever those outer belts tend to it comes near these GPS satellite, maybe cross this GPS satellite, so we have a problem with the reception of the signal, because uh, first of all, those signals are interfered by those high energy particles, electrons, as well as those high energy particle damage the spacecraft, because it can damage the computers. It can do a single bit flip, which is not what we want. So yes, so we actually need to understand these belts. So yeah, and there is one thing called what we call the South Atlantic anomaly, which you can see here in the map. And why do we call it as South Atlantic anomaly? Because this inner radiation belt, which I said that it starts at around 700 kilometers, but when they have this at around means this South Atlantic region, which is highlighted here, the belt actually comes at around 200 kilometers. So usually it is at 700, but in this region only it comes down to around 200 kilometers. So that is the reason why whenever the ISS passes over this all means this region, this South Atlantic anomaly region, the mission control keeps a close watch at the ISS computers and all those. And if any fault occurs during those time, or if any sensor reading is wrong, they tend to ignore those, because that those wrong reading, those wrong sensor readings and whatnot can occur because of the they are entering the radiation belt. So this is a fun fact here, which ISS mission control does. They have marked this area on the map, and whenever the ISS passes over it, they tend to kind of ignore certain events. And once it comes out of that belt, out of that region, then they, if anything persists, then they do some actions. Otherwise, yeah, this is what they do. Okay, so talking about the belt and everything, today what is happening actually, we have this very low frequency radio waves. Okay, and we have recently discovered that in this huge void which we have between the outer and the inner radiation belt, we have this VLF belt. You can see here the very low frequency belt, and this very low frequency belt actually protect us from the high energy particles which are on the outer radiation belt. Okay, and today, for today's mission, we are actually wanting to study those VLF frequencies only, the very low frequencies. And since those frequencies actually protect us, and since this area is variable, this void is variable because of obviously of this outer radiation belt which keeps on increasing or decreasing, so hence we can shape our our safe area around the earth, because the VLF, the very low frequencies, are actually made by humans. Okay, these are artificial frequencies which we use in all everyday activities, sonar, radar, and all those things. So those are the things which we use, and these VLF frequencies, when they they reside in this, and they keep us safe from the outer high energy electrons. Okay, so that is the case. And there is one video which you should see now, which very well explains what I just said, which we can shape the just see this video once.
They believe the bubble was formed by very low frequency waves, or VLFs. VLFs have been found to interact with the particles in space, affecting how and where they move. VLFs are used for radio communications, including with submarines, because they can penetrate deep into the ocean. The waves can also travel far into the environment around Earth. By understanding more about how VLF transmissions help shape our space environment, we learn more about this complex region surrounding us. The more we know, the more situational awareness we have to protect our satellites from natural radiation in space.
So this is the thing which we are going to see today. We want to learn about these VLF frequencies, and for today's mission, we want to see how the VLF frequency actually escape the ionosphere. Okay, and we want to study that. We know that VLF frequency actually escape the ionosphere, and let me just tell you that VLF means very low frequency, and if you apply the formula E is equal to h nu, nu is basically the frequency, you will see that it does not have a large amount of energy. So basically what happens when during the daytime, most of the VLF frequency just get absorbed in the atmosphere, reflected back, and does not just go out of the ionosphere. But during the night time, we can observe the effects. The VLF frequency slowly go out of the ionosphere. So today in the VIPER launch, we will want to study that in how the VLF frequencies actually go out of the ionosphere. So yeah, that is the case here. And let me just see if we maybe we can skip this thing. What else do we have? Okay, so this is nothing, but let's just go to here only. I can just go and keep on talking about these things, but what we are here for is the launch. So let's just have a look at the launch itself. um uh, okay, so this is the frequent means the visibility map for today's launch, guys. The visibility map for today's launch is a bit shorter, which we can see here, and the reason is because this rocket does not work, or maybe you can say that does not have that particular burn time which can enable uh, residents which are living far away to see the launch. So this is how the things will look like, and in this green region here, uh, the people here can look at the rocket for around t plus 0 to t plus 10 seconds, and then 10 to 30 seconds people in the blue region can look for the rocket. So mainly people in uh, you know um, Delaware and um, in these surrounding areas which you can see here can look to the for the launch. I don't actually know the states here, but you can actually see the map and maybe just determine how will you be able to see the launch or not. So this is the visibility map here, and we are still waiting for the launch to uh, I mean the stream to happen, the webcast to happen. We are still waiting for it, but yeah. Okay, just a sec. Let me see if we have any other update right now. Otherwise, we'll get to. And right now, we talk about what is going on in the space Twitter. mm, Bernie Sanders and all those means the HLS contract. Basically, the HLS contract about the Artemis mission has had some, you know, issues with it right now, and people are really discussing it on the Twitters. Yeah. Yes, still we will need some time. Yes, Joseph, this is a Wallops launch. So this is the visibility map which you can see, and yes, you will be able to see with this. Okay, so we don't have any as such. Please don't scrub the launch. Uh, but exactly. See, the problem with these kind of launches is that these rockets are unguided. They don't have TVCs, though. The engines cannot steer themselves to basically steer the rocket. So they mostly dependent on the weather. Although, speaking of the weather, this rocket is not highly sensitive to the weather. Uh, so yes, this does not have those concerns which we had for the Black Brent 12 rocket. So that's the reason here. Okay. And VLF is around 3 kilohertz to 30 kilohertz, very low frequency. I don't know the actual readings out of it, but basically VLF, very low frequencies, does not have much energy in it. Okay, they tend to stay inside the ionosphere only. But how does this prevents, how does this this VLF frequencies protect us from the higher energy electrons in the outer belts? During the event of solar maxima, when the atmosphere basically expands, so the ionosphere is also expands. Okay, so this ionosphere, when this expands, so the VLF frequencies can just expand with the ionosphere. So what happens that the VLF frequencies enters into that void which we have between the outer and the inner radiation belts, and then those VLF frequencies interact with those high inner energy electrons in those outer belts and kick them out, so that they don't come back towards the earth and create problem for us. So that's how the things work. That's how VLF, the very low frequency, protect us from these harmful radiations. Shmojo says it's NASA and they rarely launch on time. Uh, it depends on the weather. They have to follow some constraints which they have. So yeah, you can say that. Is it the same as the last one? Nope. This is totally different. Uh, and we still gonna look for it though. No view from Washington County. From Washington, you will be able to see John Moore. The launch, you should be able to see the launch from the Washington. So yep, let's see. Thank you so much for this stream. Thank you so much, Jimmy. And if you want to maybe support the channel, just give it a subscribe, guys. It really helps the channel to stay alive. Or maybe support me on Patreon. uh, really helps me to keep these kind of streams um, just keep on coming. And if you want to support me for one time, super chat is always enabled for that. The control center in Bermuda? No, nothing related to Bermuda this time. Everything is there in the this side only. This is the US side, US eastern side, Virginia, Maine, um, Wallops, and South Carolina. These are the places where they will observe the event. So yes. Michigan, you will have, where is the Michigan basically? Just a sec. Not very thorough with the map here, so we'll have to check where are all those states and everything. But yeah, so here we have. So people living in Michigan should look. Will they be able to even see it or not? No, 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 no. Michigan is too far away for them to see the launch, right? Yeah. From Michigan, you won't be able to see the launch. Although people living near Delaware, New Jersey, Washington, Maryland, Philadelphia, maybe New York also will be able to see the launch. So if you are, residing in New York, so you should be looking in the direction of southeast from the green dot, the center of the green dot, green circle from where the rocket will be launching. So look at the southwest to south direction. So yeah, what states are on this map? So regarding the states, we have Virginia, we have North Carolina, and we have uh, New Jersey, Maryland, all those states, all those places here. Maybe some parts of Pennsylvania also. No, no, no Pennsylvania, but Virginia, you will be able to see that. See the launch. Okay. Too cloudy in New York right now. Then you may not be able to see it, but yeah. What about Alabama? I've been working hard. Okay. Okay, since we have time right now, we can totally discuss, or do we have the launch? No, don't have the stream yet. Maybe we we have a reschedule today. Don't know. Although we do have some times till they come live, so yes, we can give them some time here. So in the meantime, we can discuss about the things which we missed. So we talked about the ionosphere, right? How the ionosphere helps this VLF frequencies, and when the ionosphere expands, the VLF frequencies can do their job to kick out those electrons and keep the earth safe. So but what basically is ionosphere, and how uh, how useful is this ionosphere? So we can see that here right now. So this is a thing which you can see.
Longing for more space, open skies, and exotic travel? Then look up, about 30 to 600 miles straight up, at the ionosphere, Earth's interface to space. Nestled far above the clouds but below outer space, this little understood destination invites you to explore its many features. Experience both the weather from Earth and the weather from space. Marvel at the ballet of radio waves and navigation signals, like GPS, leaping through this particle paradise. Sit back, relax, and take in the aurora, some satellites, and the International Space Station as they sail by. And you'll want your camera handy for one of the region's signature features, bright and colorful air glow. This daily show is made possible by the ionosphere's own swirling charged particles, because that's what the ionosphere is. It's all charged particles. During the day, enjoy the sea of particles, freshly energized by the sun. As the sun sets, this particle party relaxes and the air glow thins. Our quieter nightlife lets you gaze into clearer skies. The ionosphere is in constant motion, an amazing effect of space weather. Don't miss when solar storms rain down. The storm separates the particles even more, making this colorful region delightfully more dense in some places and stunningly sparse in others. And don't forget about storms from Earth below. Your weather from back home also stirs up this one-of-a-kind destination. Experience the unique beauty of every season, as changes in Earth's atmosphere, daily and annually, can create pressure waves, changing the ionosphere's shape and density. Venture to the equator, where our particles are packed in lush and thick. Cruise along a magnetic field line and see how the ionosphere's charged material also interacts with Earth's own magnetic field. Don't miss the superhighway of particles zipping out to space and back down to the planet. This unpredictable parade of charged particles can help you unplug and unwind. This is because the crowd of particles can garble the radio and satellite communications from home. The ionosphere welcomes you to discover more about this little-known region. After all, once you've explored this interface to space, who knows how much farther you'll be able to go.
This actually wants me, encourages me to buy a house in ionosphere. Actually, which means actually this was, this has been made so as to, maybe this is the best advertisement you can give for the ionosphere, covering each and every aspect about how the ionosphere works, what it has, what you can expect from it, and all those things. So it's a great advertisement, and yes, it encourages me to buy a house there. Okay. So yeah, this is the ionosphere, and today we will be studying this. They will be launching this rocket to around 135 kilometers to the apogee, around that only, and there they will be opening the payload bay doors, and yes, observing the experiment in which they will be actually reading it, or you can say observing how the VLF frequencies, the very low frequencies, escape the ionosphere. We already know that it escapes the ionosphere. We already have the model ready on the Earth. How do they escape? But that model is totally on the predictions, on the calculated predictions which we can do. But we never had a chance to uh, actually map or actually have a real data of the uh, VLF frequencies going out of the ionosphere. So this mission, the VIPER launch mission today, will be actually uh, a thing which will improve on the data, in which they will be able to collect the data on how it will the VLF frequencies goes out of the ionosphere. So yes, that is the case here, and we have that around. Okay, so this was the actually basically this was basically the the concentration of the electrons, and the how the absorption of the VLF frequencies happens with the um, altitude. So here you can see that at around 50 around 75 kilometers or so, most of the VLF frequencies get absorbed, and we don't actually get to hit the ionosphere properly. So but this blue line, this blue plot which you can see here, is the plot which you get in during the night time, and today during the night time only they are observing it. So absorption is less, and transmission will be more. And the altitude is also very high here, which we want to study. So yeah, that is the case. This is the ideal scenario which we are waiting, which we'll be studying for, not the normal day scenario, but the night scenario, which is here, but the absorption is less and the transmission is more. So yes, what else do we have here? I've talked about everything. No, I don't have any other thing to talk about right now. Okay, let's see if we have a webcast here. Nope, not really. Waiting for the webcast to start again. Still waiting and talking about the um, updates. We don't have as such for right now. We are still go for the launch. They are obviously looking at the weather right now, but still uh, they are go for the launch right now. And talking about the launch window for today's mission, it runs from 9:15 EDT when the window opens, and it closes at around 12 at midnight. So we do have a good amount of time for you know for it to launch. So yes, let's see how things happen. Although waiting for the coverage to begin, let's see whenever that happens, we'll switch over to that. Right now, the visibility map is on the screen, and if you have any other questions, you can ask me right now. To make a video like that for a nuclear energy, super fun says that. Actually, that would, obviously, people will criticize again. The nuclear energy is always criticized because of its radiation, but still, people who are not into nuclear energy, not, have much of the knowledge, this kind of commercials or videos can help them to uh, learn more about it. And when they learn more about it, those doubts about nuclear things just go off and people actually pursue it, because nuclear is a way forward for anything. For nuclear, actually, why am I saying nuclear is a way forward? Because nuclear energy is the right now is the energy which we can harvest, and we can get the most out of it from a small quantity. Okay, and we want that only, whether it be for energy generation or whether it be for propulsion. For propulsion also, what happens in propulsion, right? We actually impart energy to the spacecraft so that it moves, and where that energy comes in, that the energy comes in from the fuel, the potential energy stored in the fuel. So when we have that fuel, and if that fuel actually has like enormous amount of energy in it, so then we will be able to increase the mileage of the rocket, or the ISP of the rocket. So the nuclear rocket does that only for the propulsion. Uh, since the nuclear core actually has a lot of amount, lot, the that enormous amount of energy in it in a small quantity, so it qualifies as a perfect candidate for space travel, because you can make the rocket smaller and you can still have lots of amount of delta V to it. So yes, if the nuclear treaty wouldn't have been into place, we would have traveling to the Mars, like for right now it takes around 9 months to travel to the Mars. Once we have the nuclear propulsion, if the project Orion must had not cancelled, we would have been traveling to Mars for at around, the journey will be around for 3 months only, and we wouldn't have to wait explicitly for the launch windows. If you have a emergency launch or something like that, we can do that because we have a nuclear propulsion which offers lots of ISP. And yeah, yes, this is live, Ahmed, and we are waiting for the coverage to begin. Whenever that happens, I'll switch over to that. Okay. How is thrust achieved in a vacuum without a fulcrum? Doesn't this contradict known principles? No. J states, you don't actually need a fulcrum every time to actually exert any force. I'll give you a simple example, okay, for you to imagine and you to experience the force. Okay, when you hold a pipe and when the water is coming out of it, you feel a backward push when when the water goes in front of it, and means come out of it, right? You feel a backward push. If you don't understand by this example, maybe understand by a gun. When you fire a gun, you feel a recoil. Why does that happen? We actually didn't have any fulcrum there also, right? It all happens because of the Newton's third law, which states that every action has an equal and opposite reaction. So in case of rocket propulsion, what we are doing, we are actually spitting out most of the fuel out of the rocket from the backward part of it very very fastly. And because of that, the rocket which is in front of it goes in the other direction. When the particles move in the backward direction, the rocket has to go in the forward direction, because that's what Newton's third law states. Every action has an equal and opposite reaction. Every action is in the backward direction. All those particles are going in the backward direction, so uh, the rockets must go in the forward direction. So that's how the rocket propulsion works. We don't actually need a fulcrum every time to exert a force. We can have the Newton's third law also to have something like space propulsion possible. Okay. There is a massive thunderstorm in Baltimore right now. Okay. Good morning, guys, says Iron Clue Gaming. Good morning, Iron Clue Gaming. How are you? Okay. Hmm. Rocket again, does the solar radiation captured in the belt and the funnel into the poles affect the magnetic polarity of the poles? Uh, uh, Actually, charged particles interact with the, you know, obviously the poles, but they actually, disturb the magnetic field. They actually don't change the polarity as such. Polarity change happens if it happens because of the changes in the Earth's core. We know that Earth's core is the, thing which actually uh, generates the magnetic field around the Earth. The ferrous core, the liquid metal core which we have. So if we have some problems in that, obviously the magnetic field could change, and the polarity of the field could also change, but I don't think so. And then no, I would say no, these geostorms, I can't change the polarity as such. They can affect the magnetic fields and change how those fields interact, maybe compress it or expand it, and hence introducing a magnetic flux to all those metal objects out there and inducing some electricity. That's how the induction of electricity works. So that's why whenever we have a geostorm, we are, warned about the power grid failure and all those things, because uh, the magnetic field around the Earth changes, the flux around the Earth changes during the solar storm, and because of that flux change, we have induction of electricity on all the metal particles on the Earth, basically the power grids, and that could induce some unwanted current which we don't want, and can result in a failure. So yes. The plane is delayed because of this thing. Uh, if it is okay, so we have the stream, guys. I'm just switching over to that. Just a sec. Although the quality is not so great, but still, something is better than nothing, right? Okay, here you go. So we have the launch coverage, guys. I mean, so obviously we can actually now see the rocket in front of us. And talking about this rocket, well, um, this rocket is fin stabilized. I forgot to tell you actually about the spin stabilization of the rocket. For the Blackburn 12 rocket, if you remember, I said that the spin stabilization happens with the spin motors, right? But with this rocket, it does not have spin motors. What it does have is fins. And you must be wondering how fins could induce those rotation. They can very well induce those rotation if we take the cross section of the fins and make it unsymmetrical on both of the sides. Okay. Um, Whenever we make them unsymmetrical, one of the forces is unbalanced, and that induces a spin in the rocket because of the air drag. So yes, this is a fin stabilized, which means the fins are unsymmetrical, and whenever it goes up, because of the air drag, those unsymmetrical forces act on the rocket and it spins the rocket. So yes, that is the case. And I think, which I am, making this as a guess, but I am, you can say 80% sure about it, that the unsymmetrical fin part is on the top of the rocket, which means the second stage. Okay, the first stage is normal, uh, fin stabilized, means the fins, symmetrical fins we have in the first stage, but not for the second stage. Yes. Are we gonna see auroras again? No, Iron Clue Gaming. We have what we I don't think so. We are actually gonna see something here, but we can see at least some views of the space from the rocket. That could happen. The auroras formation is not the thing which we are here for. They want to study the very low frequencies, how those very low frequencies go out of the uh, ionosphere. They want to study that transmission, the propagation of those things. I read stories regarding a polarity shift. Yes, it is happening, Shmojo, and that is happening because of internal core activities. Every once in some years, the polarity of Earth changes, and whenever the polarity of Earth changes, which means the North Pole becomes the South Pole and the South Pole becomes the North Pole, not the geographical one, but the magnetic one. And whenever that happens, it actually weakens the magnetic field, and it creates some huge destructions on the earth. So we do have some time, like, I don't know, but maybe millions or thousands of years right now. But when it is slowly changing the polarity, it is becoming reversed. The magnetic field is becoming reversed. It is bound to happen. And whenever that happens, we will be bombarded with all the solar winds, the galactic cosmic rays, and all those particles coming out of from the space right down to the surface of the earth, and that could cause some serious radiation damage to all the living animals, or even the living organisms, I should say, to them. And not only the living organism, but the non-living organisms also. Computers would be affected, the power lines would be affected, all those things. But you can take a calm and a big breath in, because that is not going to happen anytime soon. Okay. Streamlabs. Yes, Streamlab is actually doing something which I can't control right now. Ignore the Streamlabs right now, okay? Just ignore the Streamlabs. I was trying to make some kind of a night bot for the chat, but somehow I managed to at ABC only. So this just go in and then publishes in the chat, if you can see it. Is this a solid fueled rocket? Mount ask. Yes, this is a solid fueled rocket. And Zero Flamed Whitey says happy birthday. Thank you so much, Zero Flamed Whitey. It would be a great birthday gift for me if this rocket launches today. So yes. Magnetic field has flipped in the past and the life survived just fine. I suspect the electrical grid will have a more difficult time. KK says, magnetic field, whenever it has flipped, I don't actually know these timings of it, but if it has flipped for like once in a million years or something like that, maybe life has re-originated from microbial beings. Obviously we have some beings which are very radiation hardened, like tardigrades. They don't they can survive high temperature, very low temperature, even radiations also. Those water bears, those tiny little water bears. So yes, life can't fully destroy when these kind of things happen, but major chunk of life could destroy. So yes. The solar radiation disappeared over distances such as levels being less at Mars than at Earth. Yes, Shimojo, you are right. The solar wind effects on Mars are pretty less than what we experience on Earth. So yeah, but you have to remember that Mars does not have a very good magnetic field to protect it from the solar winds. Those weak solar winds can also interfere with it, and we have seen that the Martian atmosphere has just eroded away as the time passed because of its magnetic field. We don't have a magnetic field there. And yes, whenever we live on the Mars, we need to figure out a way to support the magnetic field, because we need a magnetic field to shield us from the radiation, because otherwise we won't be able to terraform it. whatever we do, it will just go out, escape in the space. So yes, we need something to, and I know what we can do to help with that. And if you are wondering, oh man, we can, what about the moon? We don't have a good magnetic field around the moon also. So but moon is very near to the earth, right? Earth's magnetic field does extend till the moon, and it can somehow, can shield it on the moon. So yes, earth's magnetic field can have its effect there. The Henrof's Giving says, if the flip happens, say 1000 years from now, do you think we should have the technology in place to protect us until the magnetic field recovers itself? That would be a thing for the future. We don't actually know. We can actually predict the future, but we can't actually say what is in store for us in the future. Maybe we can have those technology to you know um um safeguard us on the earth also. Or maybe 1000 years is a very long time, so I can suspect that we would have developed pretty good technologies for space, solar system civilization. So maybe we can just go on to the other planet like Mars, or even to the Jupiter's moon Io, Ganymede, and all those things. Maybe we would have created some warp drive kind of a thing. Warp drive is like, uh I if you ask me, can warp drive be possible in future or what? I really don't think so, until and unless we make one technology which can defy physics. uh, I don't think so warp drives are possible, although wormholes are possible, and maybe we can master the wormholes for the space travel to distant galaxies and all those things. So yeah. Can I see it in southern North Carolina? Okay, talking about the visibility map. Here is the visibility map, Max. I think you can see it in southern North Carolina. Yes, southern North Carolina would be nope. You won't be able to see it in southern North Carolina as such. Maybe if you are in the northern side of the North Carolina, that too near the east coast, you should be able to see it. But yes, it's raining here in Virginia and thundering. That is not supposed to happen. I don't think so. This could launch in thunders and those rains or all those things. But let's hope we still have a good amount of launch window for this thing. So let's just hope. Uh, and yes, I was talking about what we can do to secure Mars.
TDR, so.
Okay, we
So
have.
for TD. Yes, sir. Based on the last 15-minute balloon, we are still green for main vehicle. Copy. Thank you, sir.
Okay, that is a good thing. And guys, I have made this animations for you to go with the launch, which you can see here, so that you don't miss out on the launch and you see it properly and have a great experience of actually what will happen in the launch.
And thank you for joining us this evening for the launch of a Terrier-Improved Malemute suborbital sounding rocket from here at Wallops. Launch window opens at 9:15, closes at midnight. And tonight we are launching the VLF trans-Ionospheric Propagation Experiment Rocket, or also called VIPER. It is designed to study radio waves that escape through the Earth's ionosphere, impacting the environment surrounding GPS and geosynchronous satellites, such as those for weather monitoring and communications. Countdown today has gone very smoothly. We are currently facing no issues. The weather has cooperated. We were looking at possibility of thunderstorms in the area, possibly pushing us back to the end of the window. However, those...
This is PM, go ahead.
Yes, sir. As an update to the conversation we had, V100 is currently operational.
Copy, thank you.
And the thunderstorm stayed north of us, up near the Salisbury and Maryland-Delaware line. So right now, everything is looking very good. We're expecting to pick up the count here in about 15 minutes. And at that point, you'll be hearing them start the terminal count and the poll for launch readiness.
Okay, so we are around T-minus 18 minutes
Tonight's
until the
rocket is
launch.
the Terrier-Improved Malemute, much smaller than the Black Brant 12 that we launched just 10 days ago. And so the visibility of this rocket is not like the last one. Mainly it's looking at just on the coast along Carolina, Virginia, and southern New Jersey. And looking at the clouds, it looks like anywhere north of Wallops is not going to get a very good view tonight. Hopefully some folks to the south of us will be able to see it. Just a reminder that if you're watching the launch and or the video and you're hoping to go out and catch the launch, that you usually have about a 20 to 30 second delay from actual events on the video and what's actually happening here at Wallops. Again, we'll be flying the Terrier-Improved Malemute. It's a about 40-foot tall rocket. Payload weighs about 620 pounds. The first stage Terrier, again, this is an all-solid fuel vehicle. Terrier burns out at 5.2 seconds after launch. At that time, it would be 1 mile altitude, flying at 1,261 miles an hour. The second stage Improved Malemute then ignites at 20 seconds after initial liftoff, burns out at 31.7 seconds, and then the altitude is at 11 miles, traveling at 1,170 miles an hour. Peak velocity for this vehicle occurs at D-spin when the rocket, when we want to spin up the rockets to help the control of the vehicle. And so when we D-spin that rocket, the rocket is at about 3,574 miles an hour. Apogee tonight is expected about 94 miles altitude. At that point, we'll be going 2,073 miles, and the payload is expected to splash down about 457 seconds after launch. At that point, it will land in the Atlantic Ocean 204 miles downrange.
Exactly. So yes, guys, those of you are planning to watch this launch in person, I would, give you the advice that go, outside at around T-minus 2 minutes to view the launch, because there could be some delay in the transmission here. So yes, T-minus 2 minutes until the launch, you can go. And talking about the visibility map, here we have the visibility map. It is not, this rocket would not be visible as we had for Black Brant 12, but some states can see it. We can see the South Carolina, New Jersey, Delaware, and some part of North Carolina can see it, and New York too, even New York too, if possible. So in 0 to 10 seconds, around liftoff T plus 0 to 10 seconds, with the green circle, most of the Delaware would be able to see, and then T plus 10 seconds to 30 seconds, all the other states would be able to see it. And if you ask me why the visibility map is not as large we had for the Black Brant 12 rocket, the answer is simple, that this is first of all a two-stage rocket, and we don't even have a good amount of burn time. It just, you just heard 5 seconds the first stage and 11 seconds for the second stage.
028 Terrier-Improved Malemute launching from Pad 2 ARC launcher. Please stand by for station checks to proceed with the terminal count. All stations should announce status as green or red. RC.
RC, green.
M&O.
M&O is green.
LWO.
LWO is green.
Programmer.
Programmer green.
LC.
LC, green.
LPM.
LPM, green.
PLC.
PLC, PLC is green.
PTM,
PTM is green.
ACS,
ACS is green.
SCO,
SCO is green.
Dartmouth,
Dartmouth is green.
Berkeley,
Berkeley green.
Goddard,
Goddard green.
PI,
PI green.
MM,
MM green.
SRPO, SRPO green, PM,
PM is green.
RSO,
RSO is green.
TD,
TD is green.
check 164.
All stations are responsible for reviewing the go-no-go criteria listed in the MOD. Only stations annotated with an asterisk in previous step are permitted call a hold. All the sites report red. Check item 165.
RSO, Sarway,
Go for RSO.
provide initial wind-weighted settings.
Copy. Wind weighting settings. Azimuth is 85.8. Elevation 70.2.
Azimuth 85.8, elevation 70.2.
Good read.
Check 166. LC, this is ROA.
This is LC.
Set ARC launcher to initial settings. Azimuth 85.8, elevation 70.2.
In work.
Okay, so the things are looking green for the launch right now, and we just heard the poll. We didn't had the red right now. Things are looking good
And
in
during the
that
count,
front.
we have been flying balloons. That gives us the wind speed and direction of the upper level winds, which is important for us. Launching a sounding rocket is very similar to flying an arrow. We're looking at a target, and so it's an unguided vehicle, and so we need to adjust the launch angles based on the winds in order to hit that target in the sky that we're going for.
Exactly. That's how
ROA,
sounding
this
rockets
is
work.
LC. Launcher settings are azimuth 85.8, elevation 70.2.
Good readback. Check 167.
Exactly. So basically, the things which you are seeing are the adjustment of the launcher support to actually adjust the angle as per the winds we have. And as he said, these rockets are unguided, so it's like a dark dart basically, and which needs to hit a particular target, and winds can obviously uh, you know disturb the dart from its intended trajectory, so we need to account in for the winds and change the angle accordingly. So that's how these things work. Everything is looking good. We might see a launch today, and it would be a good birthday gift for me. So yes. And guys, if you are new to this channel, I must say that I do live streams of rocket launches, space events with all the information you need to know about that launch. I do all those things. So maybe give it a subscribe right now, and I promise that you won't regret it, because the amount of
And we're
information
1
is
minute away
very
from the beginning of the terminal
good.
count. Launch window tonight is 9:15 p.m. to midnight Eastern Time.
Okay. So we are right now proceeding towards the launch countdown. Everything is looking good here. And yep, I was saying you can subscribe the channel, hit the like button right now, whatever. What are we? How many likes do we have right now? We have 125. Can we go? We have 561 watching. Can we go at least to 200 likes? Maybe 200 likes. And yes, and if you want to support the channel, you can do that. Patreon link is down in the description. Really helps the channel to stay alive, because right now also today only I just had a sleep of around 40 minutes.
10 minutes and count.
And
Start recorders.
I had to stream this launch, so yes, I had to wake up early. So now let me T minus 10 and counting. So let me just adjust the timer here.
Recorders are started.
Copy, check 169.
PLC check step 170. ACS check 171.
M&O, can you set ground station levels and confirm, record signal strength and deviation for all links, and verify nominal levels?
In work.
And payload systems are on external power. During the final terminal count, you're going through steps. There are 207 steps that we go through for tonight's launch from the count today. And it's about a 4-hour.
Ground levels are confirmed, and signal strength is being recorded and confirmed nominal.
Copy, check 172 and 173. Can you interrogate transponder and verify good 5 code?
In work.
Okay, guys. Is there a delay in the stream? Yes, there is a delay. So if you are viewing this launch, go out at around T-2 minutes and look into the sky. I'm once again pulling up the visibility map. This is the visibility map which you can see here. The green area is with 0 to 10 seconds. T plus 0 to 10 seconds is the visibility time there, and then T plus 10 seconds to 30 seconds is the blue area where the rocket will be visible. So first of all, the Delaware will be able to see, then some part of South Carolina, North Carolina, New Jersey, New York. So yeah, your voice is like 1/3 to half the volume of the loud guy. Uh, I know actually his voice is a bit
PTM check item 174.
loud there, but just tell me whether my voice is good or not. Should I increase my volume or is it good? Just tell me that. Yes, the clock is right. I have tried my best to sync it. We are T-7 minutes 26 seconds until the launch. Everything is looking good, guys. Okay, thank you so much, Brian Colonel. Panic is going good. Thank you for keeping us.
Coming up on T-7 minutes. Target launch time today will be at the beginning of the window at 9:15 p.m. Eastern Time.
Thank you so much, Elzer, for that $4.99. Thank you for keeping us educated and informed on rocket news as always. Yes, that's what I do, and your support makes me improve my content as much as possible. So thank you so much for your support, guys.
ACS check 177 and 178.
Experiment team, this is MM. Calling to verify receipt of good data. Dartmouth.
Dartmouth, good data.
Berkeley. Berkeley, good data. Goddard.
Goddard, good data.
Copy, check 179.
TMMNO, we have good lock on transponder.
Copy, check 175.
So we are heading towards the launch, guys. I think this will launch today only in the beginning of the launch window, although the thunderstorm had some we thought the thunderstorm will have some issues, but that didn't happen. So yes, now we're just waiting for it to launch. Hopefully we get a beautiful launch today, and yes, the animations will go as per the plan. The animations will be in sync with the timeline of the event. That could be a bit off for a few seconds because I don't have the official timeline. Otherwise, I have tried my best from whatever research means the knowledge I could gather to sync the times. So yeah, you'll be able to see the launch and see what is actually happening with the rocket. What's up with this crazy rocket names? Actually, they have this history of yes, the rocket launches are kind of unique here, but they have this history of naming the rocket, the sounding rockets like these. Maybe you can check that.
Check 180.
PTM GPS lock acquired, check 181.
Thank you so much, Mojo, for that 5. Thank you for answering my question. Would you please spell your first name for me? Okay, so my first name is Priyanshu, which is PRIYANSHU. So Priyanshu. Yeah.
Provide final wind-weighted settings.
Wind weighting settings are azimuth 85.5, elevation 70.1.
Azimuth 85.5, elevation 70.1.
Good read.
Check 184. LC, this is ROA.
This is LC.
Set ARC launcher to final settings, azimuth 85.5, elevation 70.1.
Launcher settings are azimuth 85.5, elevation 70.1.
Good readback. Check 185.
Yes, this would be visible in sky. Let's see how these things will work.
PI, go ahead.
Can you confirm good signal from NAA?
I confirm good signal from NAA and continuing good geomagnetic weather. We are go.
Copy that. check 186.
There you have it. The principal investigator reports that he is ready for launch.
So we are going in for the launch, guys.
In about 10 seconds, we'll be switching to internal power on the payload.
Everything is looking good. Yeah, go for the launch. T-3 minutes. It's happening. It's happening, guys.
PLC check 188. ACS check 189.
M&O, can you verify no change to signal strength and deviation for all links on internal power and verify nominal levels?
In work.
Wow, man. It's happening. It's happening. Thank you so much, Sham.
Also, can you verify good transponder signal on internal?
PM, this is M&O. No change, confirm nominal on signal strength and good lock on the transponder.
Copy. Check 190 and 191.
PTM, check 192.
PLC check 193 and 194.
2 minutes. It's happening, guys.
T-2 minutes.
Actual launcher settings are azimuth 85.5, elevation 70.1.
It is happening. T-1 minute 44 seconds, guys. It is happening. And this should launch.
Roger, copy. 9 meters.
About
ACS check 197.
Now you should head
20
back.
seconds.
Guys, you should go out to see this launch if you are near, and don't blink your eyes. This will just go straight up very, very fast.
In about 10 seconds, we'll have the poll for readiness to proceed with launch.
T-1 minute.
All stations pulling for readiness to proceed to launch. PLC.
PLC go.
PTM.
Go.
ACS.
Go.
Dartmouth. Berkeley.
Go.
Goddard. Dartmouth. PI.
PI go.
Dartmouth,
you're armed.
Copy. SRPO.
SRPO, go.
Copy. Go. ROA is Payload
Goddard,
go.
Check 203.
It's happening, guys. It is happening.
ACS check 205.
T-10 seconds.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Nishan. Whoa. Man.
9 meters tracking. Radars are tracking. Plus 10. 2, 5, and 18 tracking.
This looks so good.
Radar.
Oh, man.
Radar 3 has the booster. Plus 20. Radar 3 is tracking the booster.
Stage ignition.
Your animation is also in sync.
Plus 30.
Whoa. It's very fast. In just 11,
Plus
17
40.
seconds of burn, it achieves a apogee of around 150 kilometers. So yes, it is really fast.
Plus 50.
And thank you so much, Labrat, for that 699. Really appreciate it, man.
1 minute.
Whoa, that was so fast.
D-spin.
D-spin. CDI SEP. Nose cone squib, boom squib.
We have payload separation.
Payload separation
Should rate
confirmed.
damping.
Here, guys, we can see it. The nose cone deployed. Now the payload will deploy. Here you go. And now it is conducting the experiments, which you can see here. This is how the looks like. This is how the payload looks like.
Radar 3, track booster to splash, and they are now on the payload. 235, 18 are tracking the payload.
So, yes, guys, it happened, and we can see it. Right now, it is conducting the experiment. We will have to see how the things will look like. So, yes, that's how this sounding rocket works. It was very fast, guys. Were you able to even catch it? If you just saw it in person, if you were able to click some photos or videos, tag us on Twitter at the red rocket Gyan, and we will see your videos, photos, whatever you have taken together. So yes, not any orbit, just space. It is into the space and conducting the experiments. It was a fast, yes. Beautiful views of the space here, right? Yes, Ahmed, I was very surprised that the animations were perfectly synced with the actual events. I had totally guessed with all those burnout times and everything, but yes, it was totally synced, and we had a beautiful lift off. I think you must have missed many of you must have just missed the launch. First of all, the camera quality is not that great, and second of all, the exposure of the light was very high. So, and then when the
ACS aligning to download target with clear valve actuation.
Copy that. Good news.
okay, man, whatever it was like
Stable on
whoa,
target.
whoops, and went gone into the sky. Literally, the exposure of the camera in feed for this launch actually killed everything. We weren't able to see the actual launch because of the exposure, right? That exposure, first of all, that background light was not creating that blockage, and then when the solid rocket motor ignited, we weren't able to see anything, but animations were able to
Payload crossed 150 kilometers down.
get the views of what is actually happening. Now it is coming back down, which you can see here. Is there a schedule somewhere for future launches? Yes, flyover country. We have a launch on June 15 from Wallops again. That would be Antares rocket launch, and then we have the Minotaur rocket launch also scheduled. So, and those rocket launches will be able to, you will be able to see it properly. The Cygnus is, a good rocket. Yeah.
120 kilometers.
Yes, Joseph, it is really very amazing that instrumentation. If you go into the numbers that for the G loads for this launch, the G loads when the maximum G load was 26 Gs on the rocket.
100 kilometers.
In just 17 seconds of burn, it was able to achieve 150 kilometer apogee. See what was the amount of TWR it had. Wow, man.
kilometers. Some
Now it's
small
just falling
disturbance
back to the
seen
earth.
crossing 70, 65.
Uh,
Re-entry.
Minotaur 4, Mr. Panda, I actually don't have the proper knowledge, but it should be Minotaur 4 or Antares. I don't know, but it is for June 15. One rocket launch is scheduled for June 15. Either it be Minotaur or Antares, and I'll be streaming that. So yes, that is the case. And ROL 1111, yes, yes, March 2020. You are right. 17 seconds of 150-kilometer apogee. Man, this is a very powerful sounding rocket. Minotaur, okay, so Minotaur 4 is on June 15 and Antares is on August 1. Okay, cool. So the next launch is the Minotaur 4 we why do they launch at night, fly over country? That's a very good question. Actually, for this mission, they are studying the escape of the very low frequencies from the ionosphere. And I just showed you the plot also, if you joined in early in the stream, that the VLF frequencies actually penetrate the ionosphere and get escape the ionosphere during the night, and we want to study that escape of the from the ionosphere, those very low frequencies. So during the day that does not happen, but during the night that does happen. So that's why these instruments need to read on to that data, and hence they launched it at night. So yep, thank you so much, Kevin, for those wishes. And Lee Camster, thank you so much for that 5. You know what's amazing? I can watch rocket launches on a computer in my home. If you told me that as a kid, I would have thought you crazy. Thanks. I know, man. That is the technology has actually, progressed so further that we even can have live views from the space. Not even a rocket launches, live views from the space at home, staring on the screen. Wow. And right now, I think we don't have the stream from them, right? Yes, no stream from them. They are off air now. Fine, no worries with it. Just to see it for 2 seconds. That's how the things work with the sounding rockets. Okay. Now, we can look at the Twitter. What request and whatever you guys captured in the Twitter. Lots of buffering. I don't think so. Is it buffering? Buffering is happening or what? I don't think so. Should be good. Okay. Uh, so this is the launch which happened. Were you able to follow it? Guys, if you were able to get some videos or something like that, just tag me on Twitter. My profile is @RocketGyan, which you can see here. Just tag me and we will see those things with uh, those things together. So yes. They want to stop telling us important stuff. Okay. So they launched it. Mickey Mouse made a cameo there. The Falcon 9 Block 5 launch. There. Here. Okay. Cool. Uh, so yes, this is the thing which this argument of the statement of the
Spaceport Pad 0B at Wallops. The next sounding rocket launch from Wallops will
off here. My internet is like not giving me proper connection here or what? Can you hear me, or the stream, is this stream going good or is it not? This does not look like. I think actually this thing actually happened yesterday also. The YouTube is doing something of what I don't understand, but uh, here on my end the things look good, but the internet could be a problem here. So